Something is wrong with the mathematics of gravity. Not subtly wrong, not wrong in the way that leaves room for a comfortable recalculation. Wrong in the way that demands a complete forensic deconstruction of everything we thought we understood about how mass, momentum, and gravitational curvature interact at interstellar velocities. And it happened at Jupiter, the largest gravitational anchor in our entire solar system. The planet that has spent 4.5 billion years functioning as the ultimate cosmic gatekeeper, capturing, fragmenting, and violently redirecting everything that dares enter its orbital territory. Something passed right through it, and the telemetry does not lie. Anomalous astrometric data streams processed from deep space instrumentation in the predicted intersection window of mid-March have confirmed an extraordinary event. A hyperbolic interstellar object, cataloged under the designation 3I Atlas, executed a trajectory crossing through Jovian space at approximately 53 million kilometers proximity to the planet's center of mass, traveling at a sustained inertial velocity of 61 kilometers per second. At that approach geometry and at that closing speed, the theoretical prediction is unambiguous. Newtonian mechanics, general relativity, and every validated orbital simulation model built across the last 3 centuries of astrophysics all converge on the same output. The object should have experienced a measurable, calculable, instrumentally detectable gravitational perturbation, a curvature impressed upon its trajectory by the titanic gravitational well of a body possessing 318 times the mass of Earth. The deflection was zero, not negligible, not within observational margin of error, zero. The orbital track of 3I Atlas did not deviate by a single measurable fraction of a degree as it threaded through the most powerful gravitational neighborhood in the solar system. And that is not a data processing artifact. That is a signature. That is the universe telling us something has arrived here that does not follow the rules we wrote for it. This is not speculation. The instrumentation that recorded this event was built precisely to detect these interactions. The data streams returned by orbital spacecraft surveilling the Jovian system captured the passage, resolved the object's morphology, and documented its trajectory with high confidence precision. What they returned was an anomaly that fundamentally challenges the mechanical frameworks we use to model mass-gravity interactions. To understand why this is so profoundly disruptive, we have to conduct a complete forensic analysis of this object from the ground up. Not from the moment it reached Jupiter, but from the very molecular architecture that was forged in a stellar nursery billions of years before our own sun ignited. Because the gravitational ghosting at Jupiter is not the beginning of this story, it is the conclusion. The evidence leading to that conclusion was accumulating for months. And when you assemble every data point in sequence, a picture emerges that is simultaneously beautiful, terrifying, and almost entirely without precedent in the modern history of interstellar observation. Let us begin with chemistry, because chemistry, when decoded through the spectroscopic lens of quantum mechanics, is the most honest fingerprint in astrophysics. It does not lie. It does not perform. It simply reveals what something is made of and where that chemistry was originally synthesized. The chemical signature of 3I Atlas, resolved by ground-based observatories in the approach window of early March, is one of the most anomalous chemical profiles ever recorded for a transient solar system object. The spectral analysis revealed an overwhelming and highly disproportionate concentration of methanol embedded within the comet's extended gas envelope. Methanol is an organic molecule built from a single carbon atom, 4 hydrogen atoms, and 1 oxygen atom. In the chemical taxonomy of comets that originated within our own solar system, methanol is a trace constituent, a background character, a minor signature appearing at low fractional abundance, suppressed far below the dominant signatures of water ice sublimate, carbon monoxide, and carbon dioxide. It is present, it is not significant. It does not dominate the barcode. The spectroscopic barcode of 3I Atlas was dominated by methanol. To understand why that is scientifically extraordinary, you have to understand the mechanism of spectroscopy itself. When light from the sun passes through the gas envelope surrounding a comet's nucleus, the molecules within that envelope intercept specific wavelengths of photons. They absorb them. Because every molecule vibrates and rotates at precise frequencies governed by the laws of quantum mechanics, each molecular species leaves a specific pattern of dark absorption lines at characteristic wavelengths. Think of it as a fingerprint carved in light. The depth of those absorption lines directly encodes the concentration of that molecule. The methanol lines in the spectral output of 3I Atlas were not just present, they were screaming. The concentration indices indicated methanol saturation at levels many standard deviations above the established norm for local solar system comets. Methanol is a critical precursor molecule in prebiotic chemistry. Under the right energetic conditions, methanol molecules undergo photochemical fragmentation when bombarded by ultraviolet radiation or high-energy cosmic rays. The fragments recombine through complex reaction networks to synthesize sugars, amino acids, ribose polymers, and the foundational molecular architectures that biochemistry requires as a foundation for biological self-replication. When you find an object drenched in methanol at these concentrations, you are looking at a body carrying the raw precursor library of life itself. Not life, the upstream chemistry. The molecular toolkit that, given the right planetary surface, the right liquid medium, and the right energetic gradient, can bootstrap itself into something that eventually becomes biology. The origin story encoded in this methanol excess points not to the warm inner disk of a stellar system like ours, but to the coldest, darkest architecture in the galactic environment. A molecular cloud. An interstellar nebula where temperatures hover within a few degrees of absolute zero. In these frigid molecular nurseries floating somewhere in the broader galactic disk, carbon monoxide molecules drifted and settled onto the surfaces of microscopic silicate dust grains over millions of years. Through a slow, steady process of surface hydrogenation, free-floating hydrogen atoms encountered those carbon monoxide molecules and reacted with them systematically. The reaction product, assembled atom by atom across geological timescales, was methanol ice, layer upon layer, molecule upon molecule, built up in an environment so cold and so far from any stellar radiation that the methanol remained perfectly stable, perfectly preserved, intact across the deep time of the pre-solar epoch. The high methanol concentration in 3I Atlas is a direct chemical record of a formation environment that no object native to our solar system could carry. It is a message from another stellar system, written in organic chemistry and delivered across light years of interstellar void. And that message was just the first layer of evidence in a forensic dossier that was about to get significantly more complex. To fully understand the sequence of anomalies that culminated in the gravitational non-event at Jupiter, we have to examine what the observational record captured in the weeks and months preceding the methanol spectroscopic discovery. The behavioral profile of 3I Atlas was already deeply irregular long before it crossed the threshold of the outer solar system. And those irregularities encoded critical information about the internal structural architecture of the object, information that would ultimately explain the impossible Jovian flyby. Throughout the observational window spanning February and into March, during a phase when the comet was already moving on an outbound hyperbolic arc, already plunging back toward the frozen outer reaches of the solar system, astrometric and photometric monitoring stations recorded a pattern of violent, spontaneous brightness flares. The comet was erupting, repeatedly, unpredictably, massively increasing its luminosity output and ejecting fresh waves of gas and dust into the surrounding vacuum at each burst. Standard cometary thermodynamics are unambiguous on this point. A comet's activity is driven by the thermal energy it receives from its host star. As a comet recedes from the Sun, the thermal flux decreases with the inverse square of the distance. The sublimation rate drops. The outgassing diminishes. The comet dims. This is the established thermodynamic script, validated across centuries of cometary observation. 3.1 Atlas rewrote that script entirely. Moving away from the Sun, with incoming solar flux dropping with every hour of recession, the comet flared violently, multiple times. The photometric data showed massive increases in integrated brightness that cannot be accounted for by solar thermal input at those distances. The energy driving these eruptions was not coming from outside the object. It was coming from inside. Theoretical frameworks in cometary physics provide a coherent explanation for this behavior, and it involves a phase transition buried deep within the molecular structure of the nucleus itself. When water molecules freeze in the near-perfect vacuum and extreme cold of interstellar space, they do not have access to the slow thermal energy that allows molecules to organize themselves into the regular hexagonal crystalline lattice we see in ice on Earth. Instead, they freeze instantaneously, locking into a chaotic, structurally disordered arrangement known as amorphous solid water. Amorphous ice is metastable. It exists in a high-energy disordered state, perpetually seeking the lower-energy, ordered configuration of a crystal. It is, in a physical sense, waiting for permission to rearrange itself. That permission comes in the form of heat. When thermal energy from an approaching star penetrates the dusty outer crust of a comet and warms the amorphous ice layers beneath, those disordered molecules begin vibrating with increasing kinetic energy. At a specific critical temperature, the amorphous ice undergoes a sudden and spontaneous crystallization transition. The molecules snap into ordered lattice positions, and this rearrangement is highly exothermic. It releases trapped thermal energy in a rapid burst from within the ice matrix itself. This sudden injection of internal heat into deep subsurface pockets of volatile compounds causes those compounds to sublimate explosively. The pressure builds faster than the overlying crust can accommodate, and the crust ruptures violently, ejecting a massive plume of material into space and generating the photometric spike recorded as a brightness flare. The critical implication is this: for pressure to build so rapidly, for the outgassing to rupture the surface so violently, the internal architecture of the nucleus must be highly porous and extensively fractured. A dense, solid, monolithic body of rock and ice would dampen and distribute that pressure gradient before it achieved the threshold for surface rupture. The flaring behavior of 3I Atlas implies a nucleus that is riddled with voids, fracture networks, and interconnected porosity channels. The internal structure of this object is not solid. It is a fragile, extensively cracked sponge of frozen organics and amorphous ice. The precise quantification of just how porous that structure is required a specific observational event. An event that the geometry of the solar system delivered during the calculated alignment window of late January. Orbital mechanics brought Earth into a position of exact geometric alignment between the Sun and the receding comet. This configuration reduced the phase angle, the angular separation between the Sun, the observing platform, and the target, to effectively 0 degrees. This alignment triggers two distinct optical phenomena that together provide extraordinary diagnostic information about the surface texture and internal structure of a scattering medium like a cometary dust cloud. The first phenomenon is shadow hiding. Under normal observing geometries, when sunlight strikes the dust grains surrounding a comet's nucleus, it illuminates forward-facing surfaces while casting microscopic shadows behind every grain boundary on the opposite side. Your telescope integrates across millions of simultaneously illuminated and shadowed surfaces, averaging into a composite brightness value. The shadows suppress the net reflectivity, the albedo. But when the phase angle drops to 0, the shadows hide directly behind the grain that casts them, completely occluded from view. The albedo spikes dramatically. The second phenomenon amplifies this further. When light waves from the Sun travel directly into the dust cloud and return along the exact same geometric path, they undergo constructive wave interference called coherent backscatter. The photon wave trains reinforce each other's amplitude as they retrace the identical optical path through the scattering medium. The combination of shadow hiding and coherent backscatter produces the opposition surge, a sharp, dramatic spike in observed brightness that encodes the physical texture and porosity of the scattering medium with extraordinary precision. The data from this opposition surge for a 3-eye atlas reveals something that redefined the physical model of the object in a fundamental way. The backscatter signature was not consistent with dense, solid, microscopic rock grains. The dust particles surrounding 3-eye atlas are hyperporous. They are fractal aggregates, loosely assembled from submicron building blocks held together by weak electrostatic forces and thin organic molecular bridges. They are microscopic sponges. Their internal void fraction is extraordinary. Overwhelmingly empty space, organized into complex fractal geometries at submicron scales, with only the barest minimum of actual solid material providing the structural skeleton. If we apply the Kaku lens here, through the framework of string theory and 11-dimensional hyperspace, theoretical models suggest that the structural properties of matter assembled in deep interstellar environments, far from any stellar gravitational influence and subject to quantum vacuum energy fluctuations across cosmological timescales, may not conform to the same macroscopic physical parameters we derive from solar system formation models. The symphony of strings that underlies all physical reality at the Planck scale introduces degrees of freedom in molecular self-assembly that our standard condensed matter physics does not account for. The universe may be building things out there, in the dark, between the stars, that do not play by the rules we derived from local stellar system-bound observations. The hyperbolic trajectory itself encodes the proof of origin. When orbital dynamics specialists applied standard orbit determination algorithms to the positional data gathered across multiple observational epochs following initial detection in the summer of 2025, they derived an orbital eccentricity value significantly greater than 1. This is the mathematical threshold dividing bound from unbound trajectories in the gravitational field of a central mass. An eccentricity of 0 describes a perfect circle. Eccentricities between 0 and 1 describe ellipses. An eccentricity greater than 1 describes a hyperbola. A trajectory that arrives from interstellar space passes through the solar system under its own kinetic momentum and departs permanently into interstellar space on the far side. 3I Atlas carries far more kinetic energy than the Sun's gravitational potential well can capture. It is not orbiting, it is transiting, and it will depart forever into the galactic void, crossing the heliopause and the termination shock, re-entering the interstellar medium, continuing its journey across the galaxy until some other gravitational event alters its path billions of years from now. The isotopic composition data reinforced this verdict with extraordinary precision. When astrochemists applied isotopic ratio analysis to the resolved chemical signatures of the object, the ratios of specific isotopic variants of key elements, the proportion of carbon-12 to carbon-13, the balance of nitrogen-14 to nitrogen-15, and the distribution of oxygen isotopes did not match the isotopic baseline of any known solar system material. Not solar wind samples, not meteorites, not Oort cloud cometary material. Nothing in the established isotopic database of solar system bodies matched the elemental fingerprint of 3I Atlas. The isotopic fingerprint definitively proves that this object coalesced from a protoplanetary disk surrounding a completely different star in a different part of the galaxy at a different epoch of cosmic time. It has been drifting through interstellar space ever since, a perfectly preserved chemical time capsule from an alien birthplace, until it violently woke up under the intense glare of our sun. Which brings us all the way back to the monumental anomaly at Jupiter. The Jovian Icy Moons Explorer spacecraft, positioned in the Jovian system during the calculated orbital convergence of the flyby, returned imaging data that resolved the morphological structure of 3I Atlas with exceptional clarity. What it captured was a coma of extraordinary density and opacity. The gas cloud was so thick and so optically dense that it completely obscured the solid body at the center. No imaging system could penetrate the envelope to directly image the nucleus, and the shape of that cloud was deeply anomalous. Rather than the roughly spherical coma that standard outgassing models predict, the gas envelope of 3I Atlas was elongated, asymmetric, and distinctly ovoid, egg-shaped. An asymmetric outgassing geometry, implying that volatile release from the hidden nucleus is concentrated in directional jets in specific active regions, creating preferred outflow directions that stretch the coma into this distinctive elongated form. Now, here is the gravitational physics that makes the flyby data so forensically significant. Jupiter's gravitational force is precisely defined by the Newtonian interaction between two masses at a known separation. The force is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. At 53 million kilometers, Jupiter's gravitational influence is substantial. For a body of the apparent physical scale suggested by the volume of that massive opaque coma, the gravitational deflection should have been unambiguously detectable. The trajectory did not deflect, and that leads to only one physically coherent explanation. The mass is missing. The object is not what it appears to be from the outside. The enormous dense coma, The spectacular luminosity, the massive gas ejection rates that produced a naked-eye visible green coma at 270 million kilometers when the comet made its closest Earth approach in December 2025, all of these observational signatures suggested a nucleus of substantial size and therefore substantial mass. But the January backscatter data told a different story. The dust is hyperporous. The internal structure, as implied by the exothermic flaring mechanics, is extensively fractured and riddled with voids. When you take a physical body whose bulk volume implies mass, but whose internal structure is predominantly empty space, the actual mass collapses to a tiny fraction of what apparent size would suggest.